All right, guys, today we're going to talk about intermolecular forces. So we talked about different bonds that happen between metals and nonmetals, which is an ionic bond, and that happen between just nonmetals, which is a covalent bond. Now, intermolecular forces are forces between molecules. So intermolecular forces are forces that hold molecules together. So if I have two water molecules, the force that holds them together in my cup of water is called an intermolecular force. So the force in between the molecules is the intermolecular force. And so let's talk about bonds again. So bonds are forces that occur between atoms. This is the force that holds atoms together within a molecule, aka intramolecular force. Okay, so bonds that happen between atoms. Now there are polar and nonpolar covalent bonds. So remember, polar bonds are molecules that have different elements around a central atom, or the central atom has unshared pairs. So remember that the middle atom either has unshared pair or the middle atom has different elements around it. Whereas nonpolar bonds, the middle atom has the same elements surrounding it. These bonds are 10 times stronger than intermolecular forces. So the actual bonds you can think of as welds. So like when you weld a metal together, it is an incredibly strong bond, right? You cannot break that. It takes a lot of force to break that. Whereas you can think of intermolecular forces as magnets. Okay? So think of them as welds. When you weld two metals together, it makes a very strong bond. Now, intermolecular forces are the forces that happen between molecules. This is the force that holds molecules together. Examples of intermolecular forces are London dispersion forces, dipole-dipole forces, and hydrogen bonding forces. We're going to look at each of these. Think of an intermolecular force as a magnet. Magnets can hold things together, but they're not as strong as a weld. Now, the first intermolecular force we're going to look at is the London dispersion forces. This is sometimes called an induced dipole or just dispersion force. So, remember what polarity means. Polarity means that two ends of a molecule, one end is a positive charge, whereas one end is a negative charge. And a dipole means that I have a molecule that one end is a partial negative and one end is a partial positive. That's what a dipole is. Now, temporary dipoles happen between nonpolar molecules due to shifting electrons. So remember, within an atom, electrons are actually moving. They're moving constantly around an atom. And at some point, there may be electrons concentrating on one side of the atom. Well, what's going to happen is that electrons concentrating on one side of the atom is going to cause the other, or it's going to repel the other electrons in the atom next to it to go to the opposite side. And so what happens is that it forms this induced dipole where one side has a partial negative and one side has a partial positive. Well, that partial negative on one molecule and the partial positive on another molecule will come together. Now, this happens in all molecules, but only nonpolar molecules exhibit only dispersion. So, nonpolar molecules will only exhibit dispersion. So, this is how we can tell what type of intermolecular force is occurring. You have to be able to tell if the molecule is polar or nonpolar. So, an example of a nonpolar molecule that will exhibit dispersion forces is methane. So, CH4 has hydrogens all surrounding the carbon. That means that this carbon has the same element surrounding it, so it is nonpolar. Therefore, it's going to exhibit dispersion forces. Now, this is the weakest intermolecular force, so think of it as the weakest magnet. One other thing I want to point out is that bigger molecules with a greater mass and flatter molecules with a greater surface area have greater dispersion forces. So if you have a massive molecule that has a really, really big mass, it's going to have a stronger dispersion force because it has more electrons. And then if you have a really long carbon-hydrogen chain, these carbon-hydrogen chains are going to be able to lay on top of each other and have more surface area for that intermolecular force to interact. Now, the next intermolecular force is dipole-dipole forces. Now, this happens when there is a permanent dipole. So if you have a permanent dipole, that means you are a polar molecule, okay? So remember, polar molecules are molecules that have different elements around a middle atom, or the middle atom has unshared pairs. So attractions form between the partially positive and partially negative ends of adjacent polar molecules. Dipole forces are usually stronger than dispersion forces since the dipoles are permanent. Only polar molecules can form dipole forces. So an example of a polar molecule would be formaldehyde, okay? So remember that this is a polar molecule. The oxygen is pulling the electrons closer to itself, away from the carbon and the hydrogens. So this oxygen is going to have a permanent partial negative, and this carbon is going to have a permanent partial positive. And so what happens is that the partial negative of one end is going to be attracted to the partial positive of another molecule, and that's where those attractions happen. Now, the next one is called hydrogen bonds. So hydrogen bonds are especially strong dipole forces that exist between hydrogen and fluorine, hydrogen and oxygen, or hydrogen and nitrogen. So basically, hydrogen bonds only happen when hydrogen is bonded to fluorine, oxygen, or nitrogen. So the oxygen, nitrogen, or fluorine atom is so electronegative. So remember what electronegativity means. It means that it's going to pull the electrons closer to itself. It pulls one of the only electron that hydrogen has, exposing its proton. So in water, oxygen is pulling that electron. So remember, hydrogen only has one electron. It's pulling the electron so close to itself that hydrogen's positive proton is actually exposed on one end. So it's an incredibly strong force. And so the negative charge on oxygen and the positive charge on the hydrogen on another water is going to make this really, really strong force. Now, hydrogen bonds are only about 2% the force of actual bonds, okay? And don't get hydrogen bonds confused. These are still forces. These are still like magnets, but they're strong. They are the strongest intermolecular force. They're stronger than dispersion and dipole-dipole forces. Now, there's one more intermolecular force, and it's kind of hard to call it an intermolecular force because it happens between molecules and ions. So it's kind of an in-between kind of thing. It's in between a bond and an intermolecular force. So when an ionic compound, such as sodium chloride, dissolves in water, the water molecules arrange their oppositely charged dipole to be attracted to the fully charged ion, creating the strongest attractive force. So I said that hydrogen bonds was the strongest intermolecular force. Well, ion dipole bonds, they consider them intermolecular forces, but they're kind of in between intermolecular forces and bonds. So what happens here is that the partial negative charges on these oxygens are going to be attracted to the positive charge on the sodium, and so they're going to arrange themselves around the sodium. And that's actually how salt dissolves, is that it takes apart the sodium ions, and then these positive hydrogens will be attracted to the negative chlorine. So the partial negative charge on the water molecule is attracted to the fully charged positive sodium ion. And so here's just a summary of all of our intermolecular forces. So remember, dispersion forces, all molecules and atoms, but nonpolar is only dispersion, okay? And it has to do with the electron density, so which side of the molecule has more electrons. And this tells you the strength. So kilojoules is a way we can measure strength or energy. And so this is how much energy it is to take one apart. The next one is dipole-dipole. This happens in polar molecules only. And it happens between those permanent dipoles. So one end has a permanent partial negative, one end has a permanent partial positive, and they are attracted. Then we have hydrogen bonding. They only happen in molecules of containing hydrogen bonded to fluorine, oxygen, or nitrogen. And again, they have a really, really strong partial positive and a really strong partial negative. And then we have ion dipole. It's a mixture of ionic compounds and polar compounds. And so the partial negative charges on water is attracted to the fully positive charge of the ion.